So now that we have vector fields covered, and I want to talk about gradient vector fields. What I have here is example one. A gradient vector field, remember, is one where you have a potential function. Let's just call it a function here. It's a scalar function. It's essentially a surface of some sort. And then you have the gradient for the surface, which is the vector of partial derivatives. And so for this example, we get negative 2x, 1, and 2z. I'm going to call these p, q, and r, which is standard. All right, so here's my vector function. And, well, it's a scalar function. We're going to call p, q, and r the partial derivatives of f. And then I've got my vector stuff in here. You can look at this in the link that I'll put in the description. And then I have my vector here. Okay, so essentially it gives you the gradient vector really nicely. And so what I can do is I can make it bigger and smaller using this s. Remember, s is multiplied times each one of these vectors. And so you can make it bigger or smaller to see really what's going on here. And then you can look at it from the viewpoint of the z-axis. The z-axis. Now, I want to talk about a certain one. There's it's called a gravitational field. So here what I have is I have a large object at the center of an object of mass m at the origin, and then a little mass that's being affected by it. And then I have on my little vectors that are going toward it. So the vector field is described by this expression here, which you'll find in any multivariable calculus book or physics for that matter. And then we have the potential function here, which when I take the gradient of this potential function, I'll get this vector field here. And what Desmos 3D does for us nicely is it does all the work for us. So this is example 2 here. Let me take out example 1. There we go. And then, so what I've done here in example 2 is I put my potential function here, and then Desmos 3D, I called it P2, Q2, and R2 to differentiate it from the other ones. K is that M, and G on top. K is composed of the mass of the little object times the mass of the larger object times the gravitational constant. So I just called it K just to make it easier. And so what we see here is exactly what I was talking about previous one. So we have some large object here at the origin, and then depending on what K is, the gravitational field gets larger as you get closer to it. And then you can play around with S still to make these larger or smaller depending on what you want to do. So I think this is a really nice way to visualize gradient vector fields. And this does all the work for you, this little Desmos. So play around with it.